Hi guys! So our chemistry CBSE Board exam is completed today.
16 days MCQ challenge over.
6 hours of Maha marathon of live chemistry discussion.
Everything is over.
Right.
So the hard work is going to pay
Paid off. Students are happy.
We are happy.
Right?
Parents
also
also
happy. We will be here to achieve your goals. We are not blindly saying that there are a lot of questions came from our Maha marathon chemistry revision session.
We are here with a lot of evidences.
Yes.
Okay, the evidences will talk.
Ready.
4 minus you know that 20 it is plus 7,
straight.
here it is plus 6
Plus
and
6,
here you know that
plus
20
3.
plus 3 will come. Okay, why we are writing the oxidation number? Because there is a statement, that statement you keep in mind, higher the oxidation number, more easy to get reduced and it's a strong oxidizing agent.
We are learning mainly zero order reaction as well as first order reaction. Okay, so T half is equal to R0 by 2K. This is for which order? Zero order. This is for zero order. This is like hydrolyzed, solvolysis, racemization. These all indicating which one? That is the SN1 mechanism, stability of carbocation. So SN1 mechanism mean you have to first remove. SN1 mechanism mean you have to first remove which one? The halogen and make the carbocation. Please check stable one.
That is the basic mechanism.
Yes.
Stability of carbocation.
So can you tell me, dear student, whether the first compound or the second compound can give the carbocation faster and which carbocation is more stable? Hope you can able to yes or Ash already given the correct answer, that is allylic. Yes. This is the allylic, you know.
Yeah, allylic comes, allylic will be more stable than the primary. Here
Yes.
the second one comes primary carbocation and this is allylic. Allylic will be more
Stable.
than primary.
Allylic carbocation is more stable due to resonance. So allylic will undergo more easily. So
Now we will go to the next one, 46. See, how do you account for the following? Actinoid contraction is greater than lanthanoid contraction. See, actinoid contraction and lanthanoid contraction, you can focus. Lanthanoid contraction means from lanthanum to lutetium, okay, or cerium to lutetium. There is a gradual decrease in atomic radius or size, okay, due to poor shielding effect of 4F. So, yeah, so wherever lanthanoid contraction, you keep in mind 4F is experiencing less shielding effect, and for actinoid contraction 5F is experiencing poor shielding. Yeah. So when you compare this shielding effect, more poor shielding effect is for 5F.
where it is? Linkage, where it is?
Post-Ester linkage.
Where it is? Study what it is with example.
Amino acid, essential, non-essential.
Essential, non-essential, acidic, basic, neutral amino acids.
What about the second one? Listen to me very carefully. C6H5NO2, that is nitrobenzene. That is nitrobenzene. Okay, sir?
Yes.
Nitrobenzene. Once I am treating that one with a Fe bar HCl. Fe bar HCl means that will produce hydrogen.
Yes. One more.
That will produce a reduction.
Fe/HCl or SL/HCl they are giving.
They'll give you.
You have to write
But
the
this is the easy method and cheapest method. That's why they are using scrap iron we can use now. So anyhow they will give you what?
You will
NH2.
get aniline.
NH2. Aniline they will give.
HCl.
Then that aniline, if you are treating with NaNO2 plus HCl 0 degrees Celsius to 5 degrees Celsius, that area is called a diazotization. That is called a diazotization. Don't forget the idea, diazotization. So that NaNO2 plus HCl, okay, while it is treating 0 degrees Celsius to 5 degrees. The temperature is very, very important, correct now? Okay, so we will get what? Benzene diazonium chloride. N2 plus Cl minus, we will get benzene diazonium chloride, we will get. Okay. And this one, benzene diazonium chloride, once you are treating with the CH3, CH2O,
Yeah.
you will get
You
what?
will get benzene.
Benzene.
That two reagents you have to.
Agents.
Yeah, that many times they
Benzene,
ask.
benzene.
Either ethanol or H3PO2/water. That will come. Same will the
Benzene,
product
benzene
will be
will
same benzene.
Benzene.
Yeah.
Reaction. Wolff-Kishner reduction.
This is what we told, Wolff-Kishner and Clemmensen reduction, same type.
Yeah.
You can expect.
So
Yes,
if they
it
ask
starts.
any name reaction, mean either you can write the general equation or any example.
Yeah.
So you know
Generally
Wolff-Kishner.
C double bond O.
Just to mention which all are this aldehyde or
Aldehyde or
ketone,
ketone
when react with
NH2,
hydrazine,
NH2,
will get-
ethylene glycol
yes,
/KOH.
right, it will go double bond NH2, you will get hydrazone. And hydrazone on treated with what? Ethylene glycol.
Yeah.
Right, ethylene glycol
Glycol.
and KOH, then
You will be
heat,
getting-
the nitrogen gas
You will be getting.
and you will get what? hydrocarbon.
Difference between alpha D glucose and beta D glucose.
Alpha D glucose and beta D glucose.
See,
what we
here
call?
we can say that anomers. Anomers, they are
Anomers.
asking indirectly. Yes.
Anomers are the isomers of carbohydrate where only one carbon configurations are different. Group. Yes, we treated with the glucose. CH2OH is there, CHOH 4 time is there, CHO is there. This is our glucose.
Yes. When reacts with bromine water,
Bromine water we can
Yeah.
React with which one?
Bromine
Bromine
water.
water. It will give you what? This CHO become
Yes.
COOH.
and bromine water is a
CHOH.
mild oxidizing agent
Oxidizing agent.
that will convert only aldehyde group.
I think the answer is already there. What is the
Already
answer
there.
of this complex,
Yes.
all of you?
Cr2 plus is that already we discussed. I think Cr2 plus is a strong reducing agent because Cr2 plus readily turns as Cr3 plus by removing one electron. This process is called oxidation. You have to, but no need to write this one. You have to say that Cr3 plus is more stable due to
T2G.
half-filled, half-filled T2G. That is your answer. Okay, that you will get the one. Yeah.
Act as strong reducing agent.
2 points should be there. It readily turns to Cr3 plus and Cr3 plus is stable due to half-filled T2G.
Hydrogen.
In aldehyde, there is a replaceable hydrogen. That replaceable hydrogen, you can say that this is the function.
This is the one undergo oxidation.
Carbon is there. So, but here, you know that one.
In ketone, you know, this hydrogen won't be there. That's both side will be alkyl group. So there is a replaceable oxidizable hydrogen in aldehyde. So aldehyde undergo what? Oxidation faster than ketone. And there is one more question. Alpha hydrogen of aldehyde. You know, aldehyde is what? RCHO.
This one.
And okay, let's take an example. CH3. Then one ketone is CH3COCH3. Question. The alpha hydrogen of aldehyde. Which is the alpha hydrogen of aldehyde? These are the alpha hydrogen of aldehyde. These are the alpha hydrogen of ketone. Question. Why alpha hydrogen of aldehyde and ketone are more acidic in nature? So the main thing is what? The presence
Based on
of...
the bond you can say, yes, the C double bond or single bond H is
Ah.
highly polar.
Yes.
You know that one.
We know they are what? Electron withdrawing groups. Aldehydes and ketones are what? Electron withdrawing groups. So what happened? It make the bond between carbon and hydrogen and all weaker.
Yes, weaker bond will be there.
We can easily
Then
remove it.
Asking NiCO4 they are asking. Here in the case of carbonyl, it is oxidation state is, carbonyl charge is 0, so that's why nickel is in 0 oxidation state only. Argon 4s2 3d8. So in ground state, excited state, both are they are like this only. Nickel oxidation state is 0 only. So directly we can draw the structure. 3d8 is there. Okay, ground state we can draw. There is no need of oxidation state. That only I am telling. Ground state 1, 2, 3, 4, 5, 6, 7, 8, and here 4s also contain 2 electron. Here there is a very important thing you have to remember, guys. Here 4p is there. Okay, here 4p is there. Then what about the case of excited state? That idea you have to remember. Don't forget, excited state means whenever carbon monoxide is coming to donate electron pair to nickel. Carbon monoxide is a strong ligand. Pairing will occur. So how the pairing will occur, guys? How the pairing will occur? That is very important. So here 2, this 2, this 2, and this will come to here. This will pair up, as well as the electron from 4s also will come to 3D. 4s also will come to 3D. Then 4s is empty and 4p is also empty. Now how many are coming? 4 carbon monoxide are coming. Automatically we have to take 4 orbital, vacant orbital we have to take for hybridization. 1 4s plus 3 4p we have to take. That's why 4 sp3 hybrid orbital. We write the electronic configuration of D5 on the basis of crystal field theory when delta O is what? Octahedral crystal field splitting energy is less than that of pairing energy, and if it is greater, what will happen? I will take the next slide here. So we are having D5 configuration. If delta O is greater than P, means what? There is a strong field ligand. So T2G and EG will be having large difference. So that time, electron cannot go to EG. All the electron will be come over where only? T2G only. T2G, EG0. That's it. Okay. And if delta O is less, pairing energy is more. Whenever the fourth electron coming to T2G, again there is a pairing. There's a repulsion is more, means electron will go to, that splitting is less. So that means T2G will be filled with 3, then 2 will be go to 2. Considering cis around platinum, what is the coordination number? En is 2 only, so 2 into 2 4 plus 2 6 will come. So here 6 ligands are there. I mean octahedral only the complex. I can draw the structure like this while I am drawing. Okay, you can see here En will connect with the 2 bonds like this. This is one En and this is another En, guys. Okay, here Cl, here Cl. Okay, the entire charge is 2 plus. Okay, I am not representing that one. Okay, if you want means you can represent 2 plus. Okay, so this one 2 plus and its mirror image while I am taking. This is cis only. This is cis only. While I am taking the mirror image, what will happen? The entire thing will be reversed. Here it will be coming like you can see guys. It will be like this. Okay, it will be this En will come here. This side En will come and this En will come here. En will come here. Cl will be here. Cl will be here. 2 plus. Actually, they are not superimposable. They are not superimposable. That's why they are optically active. Cis is optically active. That idea you have to remember. Cis is optically active. If they are simply asking for one mark or half mark means directly you can write the answer. If it is 2 mark question means you have to draw the structure and you have to answer it properly. If it is the case of trans, how I can draw? If it is the case of trans, how I can draw? Platinum is there. Around it 6 ligand. I mean 6 coordination number is there. Trans means I am taking En here. Why I am writing like this? En have density 2, so that's why with the 2 atom they are connecting our central metal atom. Okay, here also another one is coming and here Cl, here Cl, this is the charge. Okay, 2 plus. And if I am taking
what is known as a racemic mixture that already we discussed. Equimolar mixture of what dextro and levo 50-50, and why their optical rotation we know. And optical rotation cancel each other, say they're optically inactive. Give equation of the following reaction. Phenol is
with a concentrate nitric acid.
I think they will give the answer fast.
Yeah, give the common name.
Come on all. Phenol.
The product has a common name. Give that common name. Give the common name.
Phenol treated with the concentrated HNO3 you will get.
Size to the. When give the answer.
Yeah, so the given the answer is what?
Picric acid.
Picric acid. Phenol to chlorobenzene
That
symbol.
is another one, very simple one.
Phenol.
Yes.
First we can just remove the OH group, right? That the oxygen we can remove. Heat, zinc dust and heat will get what? Benzene. To which we can bring chlorine with what? FeCl3 or AlCl3. We can use the chlorobenzene, and the opposite you know dose process. But they're asking salicylaldehyde, right? So salicylaldehyde means we can go for what? Reamer-Tiemann reaction. So first we can treat with the
CHCl3.
yes, we can get the CHCl to the intermediate. Then we can treat with the either we can write NaOH and last H plus. We can get the what? OH and CHO, orthohydroxy benzaldehyde or salicylaldehyde.
So predict the product of electrolysis of an aqueous solution of CuCl2 with a platinum electrode. This is what we discussed in the point we gave. See, platinum electrode means you know that one is an inert electrode.
That's an inert electrode.
Okay, inert electrode wherever you're using with the value or otherwise also you can do. We can tell a logic, sir. First, you know that one CuCl2 when dissociate you will be getting Cu2 plus
2Cl minus.
Okay, 2Cl minus you will be getting. And you know that one aqueous solution means water we have. Water dissociate H plus and OH minus. So you have two cations, dear students. Two cations are Cu2 plus and H plus. Among this one they gave the value. Which one has higher reduction potential, that will go to cathode. So I'll write over here, you know that one, we can write at cathode, okay, which will move. I gave an order as well. Cu2 plus and H plus means Cu2 plus will go, which will higher value. So we can write Cu2 plus 2 electron gives Cu. It's over. At cathode, this is the one. At anode, you keep in mind, at anode there is an order that you can remember always. Halogen will go fast than OH minus. Always you keep in mind. That only two only will ask in board exam. Okay, competitive we can write. After this NO2 minus will come, SO4 minus will come. But in board exam, these two you keep in mind. X minus also, Cl minus will go first. After that only Br minus will come. Okay, so here what we have? Here we have Cl minus and OH minus. Hope you got the logic. Cl minus and OH minus wherever comes, Cl minus will go to anode. So I'll write the equation directly. 2 Cl minus gives Cl2 plus 2 electron. So which gas will be liberated? Chlorine gas will be liberated. So
And this is the one of the
See,
expected
here,
question.
Yeah, again, attack of HI against an ether. We have 3 cases. I think all will come. Wait, this is for aromatic ether. See, aromatic ether, one thing you keep in mind, one product will be
Phenol.
That you keep in mind. One
Yes.
product will be phenol. Should not make mistake. Any aromatic ether, whether it is CH3, one product will be phenol. Then what remains is C2H5. Then you give
H,
OH,
the iodine.
that iodine with that one.
So aromatic either mean after the break you should get phenoxide ion.
One compound will be phenol. No
Yes.
doubt.
So
One
here
compound will
minus,
be-
here plus.
Yeah.
So to the minus, H will
plus
go.
there.
You'll get phenol there.
Aromatic
And
ether, whenever they are giving, one product should be this one.
Yes.
Phenol. Yes.
And so I think
One
bromine with the heat means what? That is our substitution
Free
reaction.
radical substitution you keep in mind. Br2 with heat or H nu or delta.
Yeah.
Whatever they think they are giving, that only keep in mind. H nu, light,
Yes.
sunlight, delta.
Substitution.
It's all free radical substitution.
And but we can ask a question to the students, sir. From whether CH2 or CH3,
Yeah.
will you take hydrogen? Can you say?
From where hydrogen will be substituted?
Ah, yes, Rida.
From
Rida given.
CH2, yes.
CH2 place, Br will go. Yes.
yes.
Because this place having a speciality. What is this place called? Benzylic position. This is benzylic free radical will give you.
For free radical and carbocation,
Ah.
stability order is same. Benzylic will be the most
Yes.
that you keep in mind. So here the benzylic will come.
So chlorine will be there.
will be
Here it will be
chlorine.
CH, Br, and then CH3.
Gluconic acids.
What is the effect of denaturation is one of the expected
Yeah.
questions. You know there is a native protein. When this native protein subjected to what?
Undergo high temperature
High
heating.
temperature.
High
On
temperature.
heating.
On heating
Temperature
or change in
or
pH.
any
pH.
chemical change,
Like change in pH.
pH. It become denatured. And what are the changes happening? It's a question.
structure
Yeah,
will be
it retains the primary
Primary
structure.
and secondary and tertiary structure
Yeah.
completely destroy
Primary
and it's
impact.
lost its biological activity.
This is what we told the
Yeah.
second case. Second case of addition of HI against an ether.
Yes.
See here ether whenever is added against a tertiary carbocation formation.
This is tertiary.
Then it forms according to SN1
one mechanism. So
Yeah.
tertiary if there mean please make the
Yeah, make-
tertiary part. So you will get tertiary carbocation.
Because this is the most stable carbocation, tertiary
Yes.
carbocation, then I minus will join there.
Yes. So we can
write CH3
here we can
CH3.
place the iodine
Yes, iodine over
and
here.
right
Yes,
side you will
plus
get what
the
CH3
CH3
OH.
State Faraday's first law of electrolysis. Okay, very important. You know that one. Faraday's first law, second law, important one definition. First law states that the mass of substance deposited or liberated at respective electrode is directly proportional to the quantity of electricity passed through the electrolyte.
Yes.
How much charge in terms of Faraday? See guys, this is the easy one. Even the same equation we are using in D and F
MnO4
chapter.
minus become
MnO4 minus become Mn2 plus in acidic medium. You know that one. I'm writing the oxidation state directly.
Plus
Here
7.
it will be +7 and here already
Plus
given
2
2.
plus.
So you know that one difference in electron is 5.
5.
So 5 electron is equal to 5 Faraday. Right? No sir. Directly
Yeah,
we
5
got.
Faraday.
Next one
So
is
this one otherwise called silver mirror test.
yeah. And the NaBH4, you know, NaBH4 function is what? To convert ketone. This is again we discussed. This is ketone and this is an ester. The same question we discussed in alcohol chapter also. The ketone becomes what? Secondary alcohol. So you will get the compound CH3, CHOH, then CH2, COOCH3. Note over. In second step, they are treating with an acid. So when this ester, dear all, this is an ester. Ester react with acid. What happened? It breaks to what? Acid and alcohol. So you just cut this area. You will get the acid part left side. That is CH3, CHOH. Then CH2, COOH is the acid. And right side is alcohol. CH3OH. You know this is called saponification. Yes, one
Yeah.
of the expected type of question, dear all. They will just
See.
change the compound. That's it.
The last question from the aldehyde chapter, arrange the following compounds in increasing order of their property indicated. See,
Yes. First one is
reactivity towards nucleophilic addition.
yes, there is a given.
Here, the very simple thing you have to keep in mind, bulkier alkyl group means less reactive.
Yes.
That is the easy thing. Okay. Bulky alkyl group is there means it will be less reactive, inversely proportional.
Yes.
So which one has the smaller alkyl group? CH3, CHO. Next is CH3, CO, CH3. Least one will be C6H5 because phenyl group is bulkier than any other alkyl.
Right.
That you keep in mind.
So here only we have methyl group, here methyl and phenyl group, here both are methyl group.
Yes.
Here is
So I think whenever they are learning about the cells, they have to more focus about lead acid battery and this battery and as well as
more
H2O2 fuel
chances,
cell.
more chances for lead storage,
storage battery.
fuel, and even mercury also.
Mercury, sir.
hope you all seen that evidence what we discussed in the Maha marathon session. I hope you can able to see that in your board exam paper now.
And also if you want, I mean there are a lot of questions were there. If you want to check that one also means you can go to our
Yes.
YouTube channel.
Especially numerical questions we can't able to predict it, but what all questions, what all the reactions and equations we discussed.
That area
Yes.
we already
we
covered
can able to see that more than this.
more than this. And along with that, we have to tell one more person. We have to mention one more person. That was
Yes.
our great Digesh
Yes,
sir.
sir.
He is not here today
Because
since some personal reason. Okay.
attend the session. So because today we completed the examination and we're making this video.
This video within this short time period. Okay. Everything is for you guys. Everything is for
we
you.
have to give a big thanks to our students also around
Because
6
600 watching hours actually.
Around 80-90 students, they keep on watching that video.
Keep
throughout
on
6
supporting
hours.
us. Keep on
And
supporting us
they
with
are
that much
giving
energy. Yeah.
Right, and we have to give a big thanks to our supporting staff.
Supporting
also.
staffs.
They were around 6 hour, 8 hour, and even making this video and all. They are along with us.
Along
And
with us.
Team Brilliant is always be with you. I think our next month we are going to start our
JEE, NEET and
Crash
crash
courses.
programs are there. Okay. So you can, for every updates, you can check our YouTube channel.
Subscribe our channel, so you will get the updation.
And you have to share that one with your friends also. Don't
Yes.
forget that one. Okay.
So
This is not
just
this is not an end. This is just a beginning.
Beginning.
Bye
Bye,
bye.
bye.